All right, guys, so how do you solve a radical inequality? I wrote down these steps this morning so you guys could have a better feel for it. Last week I told you to just think about it, but this week we have a better understanding with these steps that we jotted down today. Step one, solve it as usual to get rid of the square root. Square both sides, or if you have a cube root, cube both sides. But anyways, you solve it the way you normally do and you get your answer, and that's going to end up being an inequality. Graph it on a number line. That's step one. Step two, set your radicand values to be greater than or equal to 0 and solve them. And then place them on the same number line. Probably should say graph them on the same number line. And then step three, the area with the most overlaps will be your inequality answer. It might be single or compound. Okay, so these steps might not make too much sense right now, but if we just put these to the side and take a look at these two problems that we had on the board. Well, it depends what period you were in. Let's solve this one first. So let's go through this thing and solve it. Okay, so I am going to add 5 to both sides first to isolate the radical. So plus 5 there, plus 5 there. Okay, cancels. You're going to have 2 square root of x. That's greater than or equal to 8. And last but not least, we're going to divide by 2. So we're going to have the square root of x is greater than or equal to 4. And now we need to get rid of the radical once we've isolated it. So we're going to square both sides. You're going to have x is greater than or equal to 16. Okay, so we know that this is our answer. The question is, do we need a compound inequality? Is there more to this answer that we need to put on the left side? And the answer is no. Now, how do I know that? Well, this is saying that x is greater than or equal to 16. So if I plug in a 16 right here, it's going to work, right? Because it says or equal to 16. So I can plug in a 16. The square root of 16 is 4. And 2 times 4 is 8. And 8 minus 5 is 3. And it's not greater than, but it is or equal to 3. So 3 is equal to 3. It works. And any number that's greater than or equal to 16, if I plug it in right here, it is going to work. Like if I plug in 25, that'll give me a 10 because 2 times 5 is 10 minus 5 is 5, and 5 is definitely greater than 3. So any number greater than 16 will work. So if you think about the number line right there, 16, say 16's right here, and greater than is to the right, okay? So we know that we're not going to go this way on the number line, which means we're not going to get to the negative numbers that would mess up this radical. Now, let's say we still wanted to continue with the steps here, and the steps here say, step 2 is to set your radicand values to be greater than or equal to 0. Okay, so if I do set my radicand values to be greater than or equal to 0, what is my radicand value? It's x in that case. So if I take that x and say x is greater than or equal to 0, and then I solve it, well, I mean, it's already solved. I need to graph that. If I take a look at what that looks like, here's 0, and greater than or equal to 0 is to the left. And if you take a look at the instructions again, it says step 3. It says step 3, the areas with the most overlaps will be your inequality answer. It might be single or it might be compound. So, since my overlap is right here on this side of the 16, I don't know if you see that, 16 this way, right? This way over here. And that's the single inequality, x is greater than or equal to 16. Now, if it would have been an area that's in between both of them right here, then it would be a compound inequality. But because they're both going to the right of 16, then it's a single inequality. But then again, from the beginning, just using logic, if you know that your answer is greater than or equal to 16, then you know that you're not going to ever get negative numbers in here, because numbers that are greater than or equal to 16 are not negative. So you know that this is the final answer. It works. Now, if it says less than or equal to 16, then you have to really think about this number line and see where the double overlap is. So let's move on to this next one right here. This one, let's solve it. How do you solve it? You're going to subtract 1. You're going to have 4 square root of x is less than or equal to 8. we're going to divide by 4. Divide by 4. You're going to have the square root of x is less than or equal to 2. And then we're going to square this side and square this side, which will give you x less than or equal to 4. Now this is an answer. Okay, that's the answer. However, when you think about what that looks like on a number line, so you have a 4 right here, and your number line, this is saying that x is less than or equal to 4. Which way is less than? It's this way. So let's say you have a 0 over here. So what does this graph look like? It's here at 4 and it goes to the left. Okay? Now you know it goes forever to the left, and that encompasses a bunch of negative numbers, and you do not want negative numbers inside this square root. So again, step 2 says to take your radicand values and set them each to be greater than or equal to 0, right? Let me show you that one more time. It says right here, step 2, it says take your radicand values, the values inside the square root, and set them to be greater than or equal to 0, and solve them and graph them. Now, remember, when we set the radicand value to be greater than or equal to 0, you're actually just going to write x, here it is, x is greater than or equal to 0. Now, it's not that I just made this up. It's the fact that I need this guy to be a positive number. It cannot be less than 0, because that would be negative and that would mess things up. So step 2 is to take your radicand value, set it greater than or equal to 0, and then solve it. And it's already solved, so this is your answer. So let's actually graph this answer down here on the number line. X is greater than or equal to 0. You go to the 0, which is already there. Let's put a solid dot right there. Which way is greater than? It's to the right, yeah? So where's the double overlap piece? Where's the most overlap? Because that's step 3 of the notes. Where's the most overlap is going to be what your answer is. So remember, this guy right here, wait, it's not working. There we go. This guy's the answer. X is less than or equal to 4. But we need to add on something to the left side of this thing. And what is that something that we're going to add on? That the x has to be greater than 0. Here's 0, has to be greater than 0, right? So let's put 0 on as a part of this answer and put the inequality less than or equal to right there, okay? Now you're probably thinking, why did it flip, right? If it was originally greater than or equal to 0, and now it looks like the inequality, this inequality flipped, right? But it's not that it flips, it's that you have to keep the same respect. If it's opening up to the x, then it has to continue opening up to the x. I hope that makes sense. So in this case, your answer, the double overlap piece is right in between here and here, and that's why you simply put 0 on this side, 4 on this side, x in the middle, and those inequality symbols right there, and that's your compound inequality. We already wrote that up here. Okay, let's move on to another one, okay? Let's take this guy over here. And you'll see that this next one's pretty easy, okay? How do you, let's focus in on this guy first. How do you get rid of that square root? Well, you're going to square both sides. You're going to have 2x minus 7 is greater than, and if you square this side, it's going to be 81, okay? And then what do you do? Well, you add 7, add 7. You're going to have a new equation that reads 2x is greater than 88. And what do we do next? We divide by 2, divide by 2. And our new inequality is going to say x is greater than 44. Now think about that. X is greater than 44. If you go back and think about all the numbers that are greater than 44, you're talking about 45, 46, 47, 1044, any number that's greater than 44, if you plug it in right here, it's going to work, right? If you plug in 45, 2 times 45 is 90, 90 minus 7, when you do the square root of 90 minus 7, you're going to get a value that's greater than 9, right? It's that simple, right? So you don't really have to do the number line to figure out, because it's saying all the numbers that are greater than 44. There is no way that you could plug in a number that's greater than 44 that's going to produce a negative in here that would mess it up. So you're done right there. You don't have to worry about the rest, okay? Now, if it's at less than, then yeah, you better do the number line and check the rest. What do I mean by that? Check this guy out. Let's solve this guy. Well, square it. You have 3x plus 6 less than or equal to 9. Solve it. Minus 6, minus 6. Sorry about that. My phone rang. Anyhow, these guys cancel, and you end up with 3x less than or equal to 3. And let's continue to solve here. We're going to divide by 3 on both sides, and you end up with x is less than or equal to 1. Now you're thinking that that's your answer right there, okay? But because of the fact that it's x is less than or equal to 1, if you think about the number line right there, that's not going to work out, because if you have a number line and you put the 1 right here and then 0, and then you have your negative numbers on this side, and this is telling you x is less than or equal to 1, well, that means that here's 1 and less than's this way. So let me do this solid dot. Less than 1 is this way, okay? However, we know that it can't be a negative 20 or negative 50, because if you plug in negative 50 right here, you get 3 times negative 50. That's a huge negative number, and the square root of a negative number messes it up. So what we need to do is go to step 2, which is, again, on our notes. Step 2 is to set your Radicand value to be greater than or equal to 0, and then solve it and also graph it. So let's take our Radicand value. So if we're looking at this equation, our Radicand value is 3x plus 6. So if I take that 3x plus 6 and set it to be greater than or equal to 0, because I need it to be a positive value. If I solve that thing, I'm going to have minus 6 here, minus 6 there. You're going to have 3x greater than or equal to negative 6. And of course, if you divide by 3 and divide by 3, you get x is greater than or equal to negative 2. So that's your inequality that you got from setting the Radicand value to be greater than or equal to 0. So if you go to the number line, that same number line that you already have, if you go to that same number line that you already have, and you put the negative 2 right there, okay? Negative 2 is going to be over here on the negative side. And it's saying that x is greater than negative 2 or equal to, so greater than is this way. So the answer, step 3, is to wherever your overlap is most, wherever there's more of an overlap, that's what your answer is. And you could clearly see that your overlapping is right here between the negative 2 and the 1. So you are missing that negative 2 on your answer. All you have to do is put the negative 2 right there and that same symbol, and you're done. That's your final compound inequality answer. I'll make another video explaining one more. I hope this helps.